Have you ever stared at a flight price, you hit refresh, and suddenly it's changed for like no reason at all? It feels like a total black box, right? Well, what if we could finally peek inside? Today, we are diving into some really fascinating new research that uses a super clever AI approach to finally make sense of the chaos that is airline pricing.
You know, it's the question we've all asked ourselves. Is it the day of the week, the time of day, how many seats are left on the plane? And the answer is, yeah, it's all of that and a whole lot more. But figuring out how much each of those things truly matters, that has been a massive, massive challenge for airlines.
Okay, so let's get into it. Here's the core of the puzzle for the airlines. They can see every single ticket that gets sold. That's easy. But what they can't always see, especially on sites like Expedia or Kayak, are all the people who looked at a flight, thought, nope, that's too expensive, and just clicked away. Without that no-buy data, it is incredibly hard to know how sensitive we, the customers, really are to price changes.
To solve this, you first have to understand the main villain of our story, something called a confounding variable. Okay, think of it like this. In the summertime, ice cream sales go way up. And you know what else goes up? Shark attacks. So, does eating ice cream cause shark attacks? Of course not. The hidden factor, the confounder, is the hot weather. It makes more people buy ice cream and it makes more people go swimming. In the airline world, stuff like summer holidays or big music festivals are the confounders. They drive up both the demand and the prices, which makes it really, really hard to see the true relationship between the two.
And this is the perfect way to think about the difference between correlation and causation. It's super easy to see that high demand and high prices happen at the same time. That's just a correlation. But what an airline desperately needs to know is the causation. If they raise the price by just $10, how much will that actually cause demand to drop? Answering that question, that is the key to setting the perfect price.
So, how have people tried to untangle this messy web in the past? Well, let's take a look at the traditional method and, why it doesn't really work that well.
The old school way is what you'd call a direct approach. You basically throw everything into one giant machine learning model. Price, season, day of the week, holidays, the whole shebang, and you just ask it, hey, predict the demand. Seems logical on the surface, right? But there's a huge hidden flaw.
And this visual right here, it perfectly shows the problem. This direct model, it gets totally tangled up in all those confounders we just talked about. The model just can't tell what's causing what. It sees that high prices in the summer go with high demand in the summer, and it might actually conclude that high prices cause high demand, which is the total opposite of reality. And that leads to some really bad, really inaccurate pricing decisions.
And this is where the new research comes in and changes the game. Instead of trying to do everything all at once, these researchers came up with this really elegant two-stage machine learning solution that neatly sidesteps the entire confounding variable problem.
It's pretty cool.
So it's this brilliant two-step process. First, in stage 1, the AI predicts the expected price and demand. It basically learns what the price and sales should be based on all the normal, predictable stuff like the season or holidays. This filters out all the noise from those confounders. Then, and this is the really clever part, in stage 2, it only looks at how the unexpected deviations from that normal price affect sales. This is how it isolates the pure causal effect of price itself.
Okay, so the theory sounds great, but does it actually work? Well, the researchers put this new two-stage model head-to-head with the old direct method, using both clean simulated data and messy real-world airline sales data. And let me tell you, the results were, wow, just staggering.
I mean, you don't even have to take my word for it. The paper itself puts it best. The researchers state that in their simulations, the new method just dramatically improved accuracy. And when I say dramatically, I mean it. They cut the error rate in predicting how sensitive we are to price from
a whopping 25%. I mean, think about that. The old method was just plain wrong a quarter of the time. That's a business basically flying blind. But the new method? It took that error rate and just crushed it, down to just 4%. That leap from 25% down to 4%, it is absolutely massive. That is the difference between just guessing and truly knowing how your customers are going to react to your prices.
Okay, so it works like a charm in a clean, perfect, simulated environment. But we all know the real world is messy. So the real question is, how does this new model handle actual, historical airline data? Okay, so let's break down these charts, because this is where it gets really good. On the left, you see the prices that the old direct model recommended. The solid lines are all over the place, and they're consistently way, way higher than the actual historical prices, which are those dotted lines. It's just not realistic. Now, look at the chart on the right. That's from the new two-stage model. The recommended prices are so much more stable and they track much, much closer to what actually happened. This proves it's not just more accurate, it's more sensible and way more trustworthy.
So the crucial takeaway here is that this is about way more than just finding a cheaper plane ticket. This breakthrough points to a much, much bigger shift in how we can use AI to make really complex business decisions.
So why does this matter so much? Well, it combines the raw predictive power of modern AI with results that we, as humans, can actually understand and check. That means we can build automated systems that we can actually trust. And this isn't just for airlines. This two-stage approach is basically a blueprint for any industry with complex pricing. You know, like hotels, car rentals, you name it. It's all about building smarter, more reliable AI. And that leaves us with a really fascinating thought to end on. For so long, we've been kind of stuck just seeing that two things happen at the same time. But now we've got this powerful new tool to finally understand the why, to truly separate a simple correlation from actual causation. So the real question is, what other incredibly complex systems are we going to use this new power to understand next?